Well, just having answered question 8, I read on to question 9, and I wish I'd read ahead first because this is a very similar method to what we just described a minute ago. Again, different exam question from a different year, but exactly the same physics. So let's work our way through this one. Some students are trying to measure the speed of sound as shown in figure 24.1. So that's it there. Student makes a loud sound by clapping her hands. The sound of the clap reflects from the gym wall, causing an echo. So the sound's going back there and it echoes back. Another student measures the time between hearing the clap and the echo. They repeat the experiment 3 times. The results are here. 50 meters, 0.28, 0.32. Oh, that sounds a bit odd, doesn't it, that one? Student did not pay attention when recording time 3. Well, yes. Calculate the mean time for the sound for the turn to clap. Now, what they're testing here is saying, look, what are you going to do with this odd one? Are you going to include it in not? Well, we are told they don't pay attention. And to be honest, even if I wasn't told that, I'd be tempted to leave that one out. I mean, it's practically double what the other ones are. It's quite clearly an anomaly. So I'm going to ignore that one. And I'm going to do 0.28 plus 0.32 equals, divided by 2 equals 0.3, my calculator says, 0.3. Well, these are all to 2 decimal places, so let's put that 0 on there. Oh, we've got a little space for it here, 0.30 seconds. Calculate the speed of the sound for the clap. Use your answer in I and the equation this. 2 significant figures. Okay, so reading through it, distance travelled is speed times time. We're asked to find the speed of the clap. So the speed, as we've done previously, is distance over the time. The distance now, a lot of students will fall over here. They'll say, oh look, it's 50 meters. Remember, the sound's going there and back. So it is 100 meters. And the time, we're going to use this average value here of 0.30. Okay, let's chuck that into a calculator. 100 divided by 0.3. Oh, it's a third, isn't it? It's, yeah, 3.3333. La-di-da-di-da, that's what my calculator says. Now, this printout there is missing something. So, yeah, I wonder what that should have said. Let's have a quick look, see if I can find that out. It should say 3 significant figures. Hopefully it does on yours. If not, we'll have to change that. So 3 significant figures. Well, let's have a look at the first 3. They're all 3s. And then the fourth one, that's less than 5, so that doesn't round it. So 333 meters per second. Last part of this question, describe, oh no, wait, there's a part B as well, isn't there? Describe 2 ways to improve and develop their method. How could they improve and develop their method? Now, please note, it does not say give a better method. It does not say what else could they have done. It's how could they improve and develop their method. So you could go off and talk about microphones and stuff like that, but that's not going to get you any marks because it's not improving, it's changing their method. So we could have a look at, say, well, let's look at this result here. That's a big error there. So we could say repeat time 3 as clearly an anomaly. We could talk about the echo method as we previously done. We won't write all that down. We could do it over a larger distance, so they did it over 3. A larger distance, actually only we need 2. I've written 3 down. The echo method is quite a long one, so I'm not going to have that one. Larger distance between person and the wall. Okay, so we repeated that inconsistent result, the one that's obviously wrong, and we said we have a larger distance. You could talk about doing it more times and getting a better reading that way. And the last part, ultrasound. Ultrasound pulses are used by vets to scan the inner tissue inside animals. Ultrasound pulses are partially reflected from different layers. These reflected wave pulse echoes are collected by the detector as shown. So we've got a nice little diagram here. We've got the ultrasound source and the ultrasound detector. So these are all in the one, you might have seen it, transducer that the person holds. They'll put a layer of gel in between just to get a good contact between the transducer and the person. I say person, it's a vet in this case. It's near enough always pregnant women or someone with kidney stones. I haven't seen a vet one before. It's nice to mix it up a little bit. And so the sound waves, the ultrasound is sent back. It's reflected at the boundaries between the two layers, or between the layers, and you can see how it's reflected back. Right, so that's the diagram understood. Let's have a look at the question. In a scan using ultrasound pulses, three layers of tissues are detected. With each layer having a different thickness. Describe and explain. So what's happening with the reason behind it, how the results from the detector can show that they're three layers and they have different thicknesses. Okay, so describe that. Okay, so let's do the three layers first, shall we? Let's describe how it can show three layers and then explain. So let's do the layers first. So what's happening here? Well, there's going to be the reflection of the pulse. Occurs at the, I'm going to use the word boundary, at the boundary between the layers. Three layers, so that's what's happening, and explain it. So one pulse. So as the sound goes down, part of it reflects off the first layer, part of it reflects off the second layer, and another part will reflect off the third layer. One pulse produces three echoes. And then let's address the thicknesses issue. So how would it have different thicknesses? Well, the thicker the substance is, the longer it's going to take. So now we're going to have to link up this idea of the time and the thickness. So we could say a thicker layer well, it won't cause. What will a thicker layer do? Thicker layer means the pulse will be traveling for longer. So the echo is received a longer time later, a larger time later, a larger time period later. Okay. So we've described what's happened, we've given the reasons behind it, we've addressed both the key points they're doing. Always do this, always go back over your answers just to make sure you've actually answered what they've been asked. But to my mind, that's job done.